Now, that control panel that you see is, you can minimize that by clicking on the orange arrow. Now,
Okay.
you wouldn't have wanted to do it until you copied and pasted that, but you can do that, and then it doesn't take up much of your screen. It becomes a much narrower rectangle.
Okay. Oh wait.
I'm getting user
Um,
password.
should I download it and then because it's a
Try
PDF?
logging. Did you log in first?
Yeah.
And then you copied and pasted, and it doesn't let you do that.
Yeah.
I don't know. If you don't mind giving me your username and password, I'll type it in, and we'll just
Okay.
log into it from my end.
Brazier TH.
Password.
And then England TB.
England. England with an S.
No, just England and then TB.
TB. Okay. All lowercase.
Yeah.
Okay. All right. Can you log in at the same time on your end, or maybe you don't need to because you're looking at it? It's probably going to work better for you if you don't.
Yeah, I don't think I can, but that's
Okay.
fine.
Okay.
So, I guess if you click on the link again, it should work. Now that you're logged in.
Okay. Yeah. Beautiful. Yeah, for students that are getting their problems off of a computer, the online almost works better than the in-person, or it works just as good.
Yeah.
All right. So which one of these do you want to do or look at?
Let's do both because they're my homework
Okay.
or I think they're the homework. I don't know. It just said try and do them.
Okay. So ABC is isosceles.
Right.
I guess that this hash mark, can you see my mouse?
Yeah.
Okay. This hash mark here, they don't have, okay, ABC is isosceles because AB is equal to AC.
Right.
Okay. Plus the EA is equal to DE is equal to DC is equal to BC. So we know all of that. So we want to find the measure of angle CAB. CAB, this angle A, basically.
Mm-hmm.
Okay. Well, let's think about this for a moment. Maybe more than a moment. Trying to figure more angle and length puzzles. Okay. Do you have any thoughts on this?
I mean, it's not going to be a number, right? It's just going to be kind of like
No, it will be a number.
a specific number?
I think so, yeah. In other words, based on the fact that we have all of these isosceles triangles in here, we actually have 4 isosceles triangles. We have this one, we have this one, we have this one, and we have the big one, ABC.
Yeah.
So, and we know, well, let's start writing. I'm not really sure what to do, but let's start writing what we know. CEA is equal to BDA, right? Because that's isosceles. And we also know this is definitely a puzzle. Well, let's see. We know, let's start with the isosceles triangle on the left. We know that angle CBD, what you would call angle B, is equal to angle BDC, correct?
Yeah.
And let's define a bunch of those. We also know, let's take each isosceles triangle and write that. Just hoping this leads somewhere. That's the beauty of puzzles. Is you don't know immediately how to solve them, but sometimes you can figure it out by just start writing what you know. And the third one is that angle EDA is equal to angle EAD. So those are the three equations we can write based on these three isosceles triangles, and there's one more. We can say that angle CBA is equal to angle BCA. And so here's the 5 equations that we can write based on everything that we see.
Yeah.
Well, what else do we know? We know that all these angles add to 180. We also know that this angle plus this angle plus that angle add to 180. So let's start writing some of that. And I think that's the clue. We've got this angle here, which is BDC. Let's see, did I call that CBD somewhere? Yeah, I did. So let's BDC. So angle BDC, that's this angle here, plus this angle, CDE, plus this angle, EDA, EDA, equal to 180, because they're in a straight line there. And boy, the only thing I can think to do here is to write out every equation I can think of and then try to solve a bunch of simultaneous equations to figure out a specific angle.
Yeah.
Now hold on, there may be I think we're on to something with this line right here. That's going to let us get a number. Boy, the difficulty here is defining these angles. It's tough. BDC, that's the same as CBD. We also know that this angle plus both of these angles is equal to 180. This is equal to the sum of those two. So another equation we can write is angle BCD plus angle DCE is equal to angle BCE. basically taking the approach of writing everything I can that I know.
Okay.
And then at some point, we're going to be able to substitute into that equation right there to come up with an angle, a proper angle for one of these. Notice, let's take a different approach here. Notice that if we could solve any angle in any of these three triangles, we would have our solution. In other words, if you can tell me what this angle is here, then I'll tell you what that angle and that angle is. And once I know angle B, then I know angle A.
Right.
And if I knew this angle or this angle or that angle, I would also have it solved. Because then I would know this angle here, and then I could also figure up angle A. In other words, figuring up the angle, one of the equal angles in an isosceles triangle is all about figuring one angle. You can figure out the angle that doesn't have an equal angle and still figure out both of these, if you can figure out those. None of these are similar. I'm almost positive I'm on the right track here in how to go about solving this. But I would have to play around with it for like 15 minutes, substituting. In other words, if I take this equation here, the one with 2 check marks by it, and I try to substitute so that I end up with maybe 3 of these angles equals 180, and therefore one of them would equal 60, I need to be able to solve for one angle.
Yeah.
I know that that plus that plus that is 180. That's 3 different angles. I know that plus that plus that is 180. That plus that plus that is 180. That plus that plus that plus that is 180. At some point, if I do enough substitution, I think I can turn this into something I can solve. But I don't see it. Part of the reason it's hard to see is that these angles can actually be named. This angle CBD can be called DBC also.
Yeah.
So it makes it real tough to start substituting equivalents. I guess when you name an angle, you probably should always go from the left to the right. And that way you ensure when you're trying to solve a problem like this that you recognize the same angles. In other words, the way I did it, I just did it randomly. I didn't care whether I went left to right or right to left. And therefore, I may have some angles here that are equal that I'm not going to see. In other words, maybe I called EAD DAE.
Yeah.
If I write a DAE somewhere else, I'm not going to see it as the same angle. So there's definitely value in using a systematic way of naming your angles. You should always go one direction or the other. Maybe I have done that. It looks like I have gone left to right on all of these. But to be honest, let's not waste a whole lot more time on this.
Okay.
Just because it is a puzzle. It's kind of like a Rubik's Cube. I'm sure that given enough time I could solve it, but I'm not 100% sure. Other than trial and error. In other words, what I would do if I was on my own and somebody said, I'll give you $100 if you can solve this problem, I would just start plowing into substituting equals for equals and see if I can come up with an equation that I can solve.
Okay.
Okay, and it might be three simultaneous. You might have three equations and three unknowns. If you can get it to the same number of equations that you have unknowns, then you can always solve that. The problem is that there's like, how many variables here? There's 1, 2, 3, there's 9 variables. So I might have to come up with 9 equations and 9 unknowns. That's not easy to solve. So for now, let's go to the second one.
Okay. Yeah, this is what we're mostly doing, the second problem.
Okay, this looks like more of what we did the other night. Find the missing links in the picture below. K is the midpoint of HI, and G is the midpoint of J of IK. What?
So this was like power of the point or something like that?
G is the midpoint of IK? I guess they didn't draw it to scale, because G sure doesn't look like the midpoint of IK. But okay, I believe them. All right, so let's see. Why don't I draw this? Not that hard to draw. Well, that way we'll be able to fill in stuff. It was funny, I was thinking the other night, would it actually been easier to print that thing out and then just write on A is the center of the circle. All right. So let's label stuff. HI is 16 all the way across, and it goes through the diameter. So KH is what?
Wait, so HI is...
HI is 16, and it's being bisected by this diameter line, NO. So we know that KH is half of 16.
Okay.
And KI is also 8, but they've told us that G splits KI, so this must be 4 and 4. Okay. CG is 3. EF is 14. EF is 14. Let me write that down up here because I don't know how to label it like that. NO is 20. Okay, so the radius is 10 and NO is 20. Okay. All right.
Wait, how do we know the radius?
Well, it's half the diameter, and NO is the diameter.
Oh, okay, yeah.
Okay, so I don't know that that'll do us any good, but we'll keep it in mind that the radius is 10. All right, so let's look at GH. We know what GH is. What's GH?
GH is...
If you look at my diagram or look at my circle.
Okay. 12.
Okay. GD.
GD is...
That, let's see.
That has to be... Well, what we're learning today was like the lines, some of the lines have to be equal the same or something.
Well,
like if one of them is, or if, I can't remember, I feel like it's the ones that cross. Like IH has to equal the same, has to be, if that's 20, then NO is 20 or something.
Well, one thing that if you look at this, the thing is they don't tell us that this is a right angle here. So I don't know that we can safely assume that it is. In other words, is IH perpendicular to NO? They would put a right angle in there if it was. Ah. What we know is the following. If you have two intersecting chords, this is probably what you were talking about. If you have two intersecting chords inside a circle, then this segment times this segment is equal to this segment times that segment.
Yeah, that's it.
Okay. So we know here's a bunch of intersecting chords. Okay, we can figure out stuff here. Well, let's look at the chord IH that intersects with EF. We know all of the segments of IH. And we know the total length of EF. So, what can we say? We can say that IG, which is 4, IG times GH, which is 12, equals EG times GF. And it's also equal EG times GF, this chord times this. In other words, if I look at this chord CD here, then I know that CG times GD is equal to EG times GF. So EG times GF is equal to CG times GD. Well, that allows me to solve for one of these, because with equation number 1, I got EG times GF is equal to 48. So I can write 48 right there for equation number 2. And they've given me CG is 3. So hopefully you can follow what I'm writing here. So GD we've just solved for, 16. So GD is 16.
Okay.
Okay. So we've solved for GH, we've solved for GD, and they want to know KO. So can we solve for KA? Or NA. If we solve for NA, we'll know KA.
Yeah.
I don't mean NA, I meant NK. If we can solve for NK, we'll know KO, basically. Okay. Well, let's go back and look at the two chords that are formed by NO and EF. So we'll do some more of this. Let's see. We know that EG times GF was 48. So In fact, now much better chords to consider would be NO and IH. Now, oh man, I tell you what, these are tricky. You have to use simultaneous equations in all of them. That's okay, we can do it. Here, let's see. I'm first of all going to work with the chords IH and NO, okay?
Okay.
So what I know is the product of IK times KH, since they're both 8, that's 64. So I can say that IK times KH is equal to NK times KO. And IK times KH, I know is 64. So I can say 64 is equal to NK times KO. And if I now look at the two chords NO and EF, I know a lot about EF. I don't put a letter on this intersection right there. I guess it wouldn't do me any good because I don't know that measurement or this measurement.
Yeah.
Let's see, what do I know here? NK times KO is equal to 64. Aha! And NK... And I know this triangle here. Let's see, I don't know any of these angles. And I don't think I have a way of figuring them out. But if I knew that angle, I would know this arc. No, I wouldn't. I would know that arc minus that arc, or plus that arc. GF. I know GF, don't I? Yeah, I know that EG times GF was equal to 48.
Yeah.
And so GF was equal to GF times EG was equal to IG times GH. That's where I got the 48. But I don't know EEG. Didn't we just solve for that? I solved for GF? No.
Well, we did 4 times 12 was equal to EG times GF.
Okay. And then, what else? That line is also intersecting with this line here. And I know CT, and I know GD. So I should be able to solve for GF because, no. EG times GF is equal to 48. I also know that EG times GF is equal to 3 times 16. It's also equal to 4 times 12. I still haven't solved for EG or GF individually. Now hold on. No, I don't know how to do that. Find the missing links. K is the midpoint of HI. We've used that. G is the midpoint of J of IK. We've used that information. What do you know about HI and NO? HI and NO. Well, you know that NO
is 20.
And you know that HI is not really bisected, because we don't know that's a right angle.
And HI is 16, right?
Yeah. So I guess what you know about HI and NO is that IK times KH is equal to NK times KO. But we don't know NK. NK is only a part of the intersection of two chords, and that's NO and I8, nothing else. Well, NO also intersects the chord EF, but that would not help us. What do you know about HI and NO, and can you prove it? What are they trying to get at there? What is it that we need to know about HI and NO? Can we prove it? I'm sorry, Thomas. I'm not much help tonight. But if nothing else, I've shown you how the online works. It's just, I wouldn't be doing any better in person, I can assure you.
Yeah. No, we just learned these today, and they're pretty confusing, so I'm not, like, behind or anything.
Okay. Yeah, these are more like puzzles than they are. In other words, we don't have that many theorems to draw on. The primary theorem that is important is this one. Since everything's inside the circle here, the only thing we have to go on really is intersecting chords. And we know that this times that is equal to that times that. And so we want to use that information multiple times to solve this problem. And I don't see what else, not only this information, but the information they've given us also to solve this puzzle. What I'm wondering is if GK is equal to IG, does that mean EG is equal, no, they don't even put a letter on that, so I don't think we even consider ourselves at that point there, do we?
No, I don't think so.
Yeah. I don't know. I hate to waste any more of your time. Why don't we go ahead and call it a session here?
Okay.
And I'll think about this more, and if I come up with something, maybe I'll call you and let you
Okay.
know. All right? I
Yeah.
hate to leave it like that, but unfortunately
No,
I don't
it's
know what
fine.
else to do.
Yeah, as long as I have like work and stuff, it's fine. And
Okay.
like I said, we just learned it, so
Yeah.
we're gonna be going over it for the next couple weeks.
All right. Well, I'll be kind of curious as to how he solves this,
Yeah.
or she. Is your teacher a male or?
It's a male, yeah.
Okay. All right. Well, the way you sign off when you get ready to leave is you just click on the X in the Go to Meeting control panel,
Okay.
and I'll